Okay, continuing with number 21, section 6.3, MAC 1114. We had just finished figuring out all the sides of the triangle. They gave us two of them, the hypotenuse and the horizontal leg, based on this information here. Used Pythagorean theorem, which is hypotenuse squared is equal to leg squared plus leg squared. Subtracted 576 from both sides. That left me with 49, and then I took the square root of both of those numbers, resulting in the 7 that you see here. But since you're in territory, your triangle's in territory where y values are negative, you need to be using -7 there. Okay, so Pythagorean will give you the positive value, and then you attach negatives as appropriate to whatever quadrant your triangle is in. So sine, now if you go and try and find all these values, the one thing you can get right from the directions is the secant value, because that's just a reciprocal of that. So you can go ahead and just flip that over and not really even have to look at the triangle. Sine, that's going to be y over r. We did find that y value being -7, and the r is 25. Tan value is y over x. Again, we found that y value ourselves. The x was given to us. Cosecant, that is going to be the reciprocal of sine. We already did sine up here, so I'll just flip that over. So 25 over 7, put the negative at the top or the bottom if you want. Cotan, just flip over your tan answer that you already have. So if you flip this over, it'd be 24 over 7, and it will be negative. Okay, there's all the rest of the answers. Okay, and then there's one problem here about, well, there's actually already another question, but it didn't have a number in there, where they're trying to see if you understand who's even and who's odd. Remember, there's only two even functions, which are cosine and secant. Those are the even ones. Try to memorize the two oddballs, because all the rest of them are ones that stick out, because all the rest of them are odd functions. So anyway, this is one of the even ones. Just trying to tell you that this is the same thing as cosine at 60 degrees. The impact of the negative is, it just goes away. It has no impact. So you can just tell me, what's the cosine at 60 degrees? Do not use a calculator. Hope you understand this, that when you are showing your work on a test, when it says do not use a calculator, you may not have a decimal answer. I want to be very clear about that going into the first test, because if you give me approximate answers rather than exact answers, when it says do not use a calculator, you wouldn't have to show any of the work or draw the picture, which means you literally know nothing about how to set the problem up. Putting something in a calculator does not mean you understand anything. It just means you know what button to press, and doesn't show understanding. So here you're showing that you understand what it means to rotate to 60 degrees, and that you can create a triangle from this by dropping to the x-axis, and that where the 60 goes is here, not up there. You don't have to show anything of that when you're doing a calculator. Then by putting the numbers here, you also show that you understand what a long leg is and a short leg is. You also show that you know what the values are associated with a 30, 60, 90, rather than letting the calculator give them to you. And these values are exact. They are not decimal approximations. Whenever you are working with a special right triangle, 30, 60, 90, or 45, 45, 90, we're talking about a unit circle. And so the radius or hypotenuse is 1. So if you want to do the cosine value, you're not just showing that you understand even and odd properties, because there's literally nothing to do other than what you've memorized. Cosine and secant, they're even. That means the negative does not impact it. So you could calculate this as though you were just asked for cosine of positive 60. Then this shows that you understand everything from 6.1 to 6.3. This is what we're going to keep doing throughout the whole class. Cosine of 60, defined as x over r. X value here is the 1/2. The over 1. So that's your answer there. Okay, I believe that's the last problem, and it is. So that concludes